I'm going to talk today about the coming commoditization of computational thinking and its impact on computer science and data science. This is in lieu of a talk I had planned to give on the vision and priorities for our new school, which you can see at this link if you go to my generative AI playlist at my YouTube channel. About 5 videos down, you can watch that if you want to see that. This is a much more interesting and I think relevant topic for this group. Many, many years ago, I found a report from Microsoft Research on trends in computer science enrollment. This goes back to the early 70s and up to about the 2004 timeframe. And it's kind of a camel-looking chart. And there's some interesting things in this chart. First of all, when I was here at William & Mary, the first spike in computer science enrollment took place in the early 80s. And at the time, people thought, if I don't have a degree in computer science, I'm not going to have a job. Well, it turned out that that wasn't right. And it turned out also that programming in those days was kind of hard. We had punch cards when I first came here. So there was a trough when people realized they still could get a job without a CS degree. Flash forward 15 years or so into the mid to late 1990s, and people thought, if I don't get a CS major, I won't be a millionaire. Well, we all know what happened to that. The dot-com bubble burst, and there was a very dark time for computer science enrollments. And I asked myself the question, what's happened in the intervening 20 years or so? How can I find this out? Well, of course, what comes to the rescue? ChatGPT. If you go and take a look at this link, which is the session I recorded to do this, and I'll send these slides out so you can take a look. I went and asked ChatGPT with deep research to tell me the rest of the story, what's happened in the past 20 years. And it told some interesting things. One thing it told that's very important for the computer science department is they get $1.4 million a year if we continue to have 121 majors in computer science. Well, the question is that trend going to continue? Now, you might think at first glance, well, of course it is. It's been growing and going up for a long time. But we're going to take a twist to this, and this becomes a much more interesting question. The second interesting question of this is a great example of low-code, no-code computational thinking. I just had an interactive session with ChatGPT and deep research, and it came up with this. Would I take these numbers to the bank? Maybe not, but it's trivial to replicate this if you want to try finding a different source of data and see what you come up with. So I encourage people to try it out. Then I got even more creative. I thought, what's been going on with data science over the past decade? And of course, I couldn't go back 50 years because there wasn't any data science back in those days. So starting at about 2015, you can see there were a handful of places that were doing this. And there's a couple of interesting data points here. First of all, while data science is still fairly low, there's more women than men, which I thought was quite interesting. And second thing, it's on a pretty good increase the last 5 years or so. Once again, a good example of no-code computational thinking. How did I do this? What is deep research? I suspect you all know what it is, but basically it's a way of being able to do generative AI by autonomously conducting multi-step research that will browse the internet and then analyze a bunch of things. And it's basically like having a team of very talented postdocs do your bidding. And it's amazing. It is going to be absolutely transformational. And it's been out, what, a month and a half at this point? So this is going to be great. So let's focus on the real topic of the talk, computational thinking. What is it and why does everybody need it? Computational thinking is actually a term that was coined by Jeanette Wing, who was a CMU professor who went to the NSF, and this was her thing. It's basically about using logic, decomposition, patterns, automation, abstraction, generalization, and so on, in order to be able to solve problems. It's not necessarily about coding. It's more about turning complex problems into clear step-by-step solutions that humans or machines can execute. This has been going on for a long time. This is not a new idea. But up to this point, up until a year or two ago, if you wanted to do computational thinking, you pretty much had to use traditional programming languages like R or Python or C++ or Java or, God help us, JavaScript. But the problem with that is attaining programming language fluency in those languages is tough because you have to wrestle with a lot of accidental complexities that have nothing to do whatsoever with whatever domain problem you're trying to solve. It has to do with the programming languages and their idiosyncrasies. Syntax and semantics, memory management, concurrency control, fence post errors, buffer overflows, all these things that drive people crazy when they take introductory courses, especially courses in programming. Let me give you an analogy. 120 years ago, if you wanted to drive a car, you had to know how to build a car. 70 years ago, if you wanted to drive a car, you had to know how to maintain a car. Nowadays, if you want to drive a car, you pretty much have to know how to put gas in it or plug it in, and that's about it. And what's happening within weeks or months? You don't even have to know how to drive a car. You have to know how to walk out and think or type in or say where your destination is, and it'll drive you there. So what's the analogy with computing? Well, if you go back, say, 70 years ago to the dawn of computing, if you wanted to use a computer, you had to know how to program and build programs from scratch. In fact, you really had to build a computer at some points, if you remember people who went to Radio Shack and so on. 40 years ago, when I was here, if you wanted to program, you had to know how to write in a third-generation programming language and learn how to debug manually. How many of our courses are still taught this way? Nowadays, if you're on the cutting edge of programming, you're not writing a lot in third-generation languages. You're not doing a lot of debugging manually. You may do some of it, but you're really installing libraries, using frameworks, using middleware, plugging into APIs, and you're assembling your programs with tools. But just like the driverless car will obviate the need to even know how to drive, where we're headed with this stuff for computational thinking, soon you won't even need to write much, if any, code. You'll describe what you want in natural language, and the AI will generate and adapt the solution. And I argue that we're already there, not for everything, but for a lot of things. And if you want some fun, and Dan is actually the one who turned me on to this, Windsurf, this really cool tool that's an IDE that mixes code writing with prompting. It's under consideration to be bought by OpenAI for $3 billion. So clearly somebody thinks there's some value in this approach. So what's the consequence of this? Anybody nowadays who has a computer with a web browser can learn to become proficient with prompt engineering or prompt artistry, which is really just about using structured interactions with large language models in order to solve complex problems. And there's other things you need to learn, like prompt patterns and so on and so forth. So you don't really have to do a lot in terms of the learning curve to get to a point where you can be very productive. This is lowering the barrier to entry in technical fields, creative fields, entertainment, business, finance, just about everything. And as I always like to say, for the low, low price of 3 cups of the most expensive pumpkin spice latte from Starbucks, which is about 20 bucks, you can get access to really good things. In fact, as I just learned yesterday, the free version of ChatGPT, not to mention Gemini and Claude and so on, actually contains almost all the tools. You just don't get as much of them. You don't get as many things. They're metered, but you can get access to some great stuff out of the box. What's the consequence of this? We're now entering a phase where you can conduct a tremendous amount of computational thinking without having to be proficient in programming language. Now, for the computer science majors, that's a little bit shocking, and I don't think they're going to go away anytime soon. But for everybody else, this is liberating. When I was a professor at Vanderbilt, I can't tell you the number of times faculty would come from biology or chemistry or divinity and say, we want to use computational thinking in our research. Can you help us? And in those days, which is a couple years ago, we would say, sure, we're going to teach you Python. We're going to teach you R. We're going to teach you C++ or whatever. And then they'd go away and say, I guess I don't really want to do computational thinking. Well, that's not what they wanted to do. They just didn't want to have to learn to be programmers. So it's the non-computer science specialists, of which there are legion, who are really the ones who are going to be able to leverage it. Here's a really fun example that I did about 1.5 years ago. I was actually going to a faculty retreat at Vanderbilt, and we wanted everybody who went to the retreat to send us one sentence of what they wanted covered at the retreat. So we had 35 faculty, 35 sentences, and my wonderful associate chair colleague, Julie Johnson, she's like, okay, let's sit down and we'll look at those 35 things and we'll kind of decide what groups together and how to cluster them, and we'll pick out how to group people. I'm like, are you kidding me? So of course we used ChatGPT to come up with the 5 clusters of topics that were relevant. And then she said, okay, fine, we've got the topics. Let's give a survey using SurveyMonkey to the faculty so that they can tell us what are the groups they'd like to be involved with. And each person has to say their top 3 choices by number. And then we'll sit down by hand and we'll do all the allocation. No, we won't. So we had the SurveyMonkey, we got the results back. And then, of course, what I did is I said to ChatGPT at the time, which was a very early version, this is back when it was still Advanced Data Analysis, or ADA. Here's input for 35 faculty members and their top 3 topic preferences ordered from the highest to lowest out of a total of 5 topics. Please generate an output that allocates all 35 faculty members to 5 topics, balancing them evenly, taking their ordered preferences into account. And then please give preference to faculty in the order they appear below, which was the way that they actually did this. So here's the actual ChatGPT session, and you can see that I gave it a little prompt pattern. This is what the input looks like. Here was all the names of the faculty members and their order of their list, and you'll notice that Jonathan Sprinkle, who is now the chair of CS, he was a laggard, so he didn't give his result to the very, very last minute. And ChatGPT went and chunked this up, and it came out very quickly with an allocation. But you'll notice, poor Jonathan Sprinkle, because he was late to the party, he didn't get any of his choices. So he got stuck in topic 5, and he didn't want that. And why did this happen? Because ChatGPT chose a greedy algorithm, which has the problem that you end up with this kind of output. So I said, hey, your greedy approach, it ended up allocating him to a topic he wasn't interested in. Can you use a different algorithm? So it went through a whole bunch of different steps. It tried another approach. And once again, Jonathan just can't make it. This guy, he's off the show, right? He's been voted off the island. So then I finally, through a series of things, it figured out it was going to use randomization. And it finally was able to generate Jonathan to a topic that he cared about. So it took me a couple of times going through this, But compared to doing it by hand and compared to writing a program to do this, took no time at all. But it was a great example of computational thinking with no code whatsoever. Now, where are we headed? And again, I give hats off to Dan for turning me on to this. So large language models are now embedded in pretty much all interactive development environments, and they can take natural language and generate it into robust code, and they can take code and then you can refine it, and it's a hybrid approach. Here is Windsurf IDE, where you've got your code window here on the left-hand side, and you've got your chat window here on the right-hand side, and you can interact with it either all way you want or both ways. This is so handy for certain things. It's also great because it'll generate comments that are actually relevant to what the code says. Most software engineering students chafe at that. They don't want to have to write the comments. Their attitude was, if it was hard enough to write, it should be hard to understand, which is not a good idea, of course. So tools like ChatGPT and Copilot and so on now allow computational thinkers to analyze data, generate simulations, write scripts, build interactive tools, and it bridges the gap between the ideas we come up with and their implementation. So we're closing that gap between domain knowledge and how we express that in solutions. So I've been having some fun thinking about use cases to apply computational thinking across many disciplines here at William & Mary, not just computer science. And the cool thing about this is you can do all of this without writing a single line of traditional code. This is the example that I just talked about, which was mapping professors to discussion topic groups. I went and used this on the very latest ChatGPT. This is the O3 model. And what was interesting about this, it also has a sense of humor, which wasn't there before, which is kind of cool. This is a diagram where I gave ChatGPT the link to the session that I'm about to show you, and I said, please visualize what's there. So it generated this. This is the first one, greedy allocation. It came up with the names. Greedy allocation, you'll see that it had put 29 people in their first slot, 3 people in the second, and 2 people got their third choice, and poor Jonathan Sprinkle didn't get in there at all. Once again, right? But then it did a backtracking algorithm that it came up with, and it was able to allocate everybody, and then it visualized what it did. So let's go take a look at what that looked like. Here we are. This is the new version, and you can see it's O3. Same input. It told me, because it's a reasoning model, it told me step by step what it was doing. Here are the results. Once again, Jonathan Sprinkle's 3 favorites were already full, so he nobly volunteered for topic 5 to keep things perfectly balanced. True department spirit. I'm like, this guy's got a great sense of humor. This is like some kind of snarky thing I'd say. I think it trains on you, right? So it knows who you are, so it probably actually did it on purpose. So then I said, once again, your greedy approach ended up putting Jonathan in a group he didn't care about. Please redo this. And so this time it went off and thought, and it came up with this backtracking algorithm. It then was able to put him where he belonged, which was great. It said something funny somewhere about each topic seats precisely 7. Jonathan gets to keep his dignity. So how's that for knowing how to not just have IQ, but EQ? Isn't that great? And then I said, please read this session and then tell me what you did. And so it thought for a few seconds and it came up with these things. And then I used that in order to be able to generate the image that I showed you. Pretty darn cool example. ChatGPT is getting better. It's getting funnier. What's not to like? There's lots of other areas where you can do something similar. Those of you who are familiar with Shakespearean literature, there's this huge controversy about who wrote Shakespeare's plays. And so you can use these tools to do stylometric analysis, and you can find out, was it Christopher Marlowe? Was it Francis Bacon? Who did it? So here we have the ghost-written Shakespeare, and then we're trying to figure out who actually wrote his plays, which I thought was super cool. Similar kind of things, if you read this article here, they use LLMs to be able to do k-means clustering on protein data for biology without writing any code. You could probably do this with a Python script pretty easy, but why? And you can simulate supply chain disruptions, generate a Python simulation from prompts, and if there's something that goes wrong, like there's a dock workers strike or a truck drivers strike, see what would happen to the economy. Sociology, my original major and master's degree here at William & Mary. You can take raw data and you can use AI to do various kinds of analysis on it, summarize trends and narratives, give it off to a human to analyze it further, and most of this could be automated almost completely using the AI tools without having to write any code. So what are we doing here? There's really 3 layers of computational thinking that we're commoditizing. The first is problem abstraction. How do we come up with a vague idea and then tell the LLM and get it to refine us? And I've been using this for great effect in a lot of things I've been doing recently, where I've got a general idea of what I'm trying to do, and then I give it to the LLM and it refines it, and then I take that and I feed it back to the LLM and it keeps refining it further and further as I go into the problem I'm trying to do. So you can basically translate vague problems into structured prompts. Then you can use AI to do automated design or automation design. It scaffolds the algorithms in natural language. You can tell it what to do in human spoken language. And then finally, it'll actually generate what you need to generate. And that, I think, is the new paradigm. In fact, the real new paradigm is to go from problem abstraction into implementation without even having any code at all. I was talking to a colleague who's a famous software engineering professor at CMU recently, and I was explaining my view on computational thinking, and she said, I'm not so much interested in how AI can generate an algorithm. I'm interested in how AI can tell us what algorithm to generate. And I'm not even interested in that. I want to skip that whole step together and have AI generate a solution to a problem I'm thinking about. And the algorithm that's generated, I really don't care. That's something that's an implementation detail. So where are we headed with this? Knowledge work, which is what we do largely, is becoming computational at scale and commoditized at scale. And that's the scary part. Why is that scary, you ask? Well, historically, automation has displaced people in manufacturing jobs, manual labor. Increasingly, we're replacing people who do knowledge work or providing the opportunity to displace people who do knowledge work. I'm sure you've heard the quote many times that AI won't take your job, but somebody who knows how to use it better than you may take your job. Why does this matter to us? This matters to us because of articles like this one that appeared just the other day from Fortune magazine, which said, nearly half of Gen Z and millennials say college was a waste of money. AI has already made degrees obsolete. So people are starting to say, why bother going to school and paying all this money? And I get out and I'm working as a greeter at Walmart or a barista at Starbucks. Why don't I just learn to do this stuff myself through Coursera and all the other YouTube videos and then get a job in the workforce because I know how to do this stuff? Or go to a much cheaper place like a community college and do the same thing. As we'll see in a moment, you can also go to other places around here and get an interesting AI sprinkled education in arts and sciences. So the challenge for us is how to think through the coming disruption that'll be caused by this. The question that I think we need to think through, and this is from the computer science point of view, but there's a bit of data science here as well. Should everyone still learn to code? And everyone being people who want to be computational thinkers. And I think the answer is still yes, but not for the same reasons and not in the same way. I think we're going to move away from just doing things with all the spaghetti-laden accidental complexities of writing programs the old-fashioned way to a lot more prompt engineering, or even more likely, the hybridization of those things, where people are using prompt engineering along with more sophisticated IDEs. What should we do to rethink the curricula? Well, we should be focusing, among other things, not to say that we don't do other stuff too, but we should be teaching our students to collaborate with AI, how to design good prompts. That's about prompt engineering or prompt artistry, how to interpret the output of LLMs and AI in order to make sure that they do sensible things. That's where the critical thinking skills that we do here with our liberal arts and sciences and humanities brethren and sisters and so on, that's where that comes in, because we're in a much better position as people who think holistically to compete relative to people who just know how to use the tools and then uncritically accept the outputs. And of course, what I think we need to be doing is applying computational thinking as a foundational literacy. The way to do it is through the approaches we're talking about here, with some tweaks as the world evolves. Now, it's not all unicorns and rainbows. There are challenges. One of the key challenges that you're all aware of is the risk of oversimplification. Especially the early versions of LLMs, when used improperly with the freely available versions, would tend to hallucinate wildly. This has been improved quite a bit, and a lot of people don't recognize the changes that have taken place within the last month. More and more of these tools are moving from what we're calling the standard model, which is what we've had up to this point with ChatGPT 4, where you ask a question and it just sort of blurts out the response, one auto-completed word after another on the screen, to a reasoning model where it takes its time and thinks and iterates and cogitates, if you will. So these are the O3 and O4 models. And then if you want to roll into that deep research, which goes off for quite a while, it's a whole other ballgame. This means that we're driving down hallucinations quite a bit. Not perfect, but if you know what you're doing and you have some domain expertise and critical thinking skills and you trust but verify and so on, you can get most things done with very few mistakes. That's where education comes in. There's also this need for metacognitive skills. It's not enough just to say, oh, AI generated it, so it must be correct. We have to make sure that we think about what's happening so that we know what to do when it goes off the rails. The point of that is computational thinking makes a lot of things easier. More people can get access to it, but there's still room for all the great skills that we teach here more holistically about critical thinking and rigorous thinking. And the other problem is we have to watch for brain rot for people who are like 5 years old. We all had the luxury of going through the critical thinking process from a very early age. There wasn't a ChatGPT to outsource your brain to. But there are people who are born today and people who are probably getting into elementary school who will never live in a world where there isn't an AI crutch that they can turn to let them get the answers without having to do the critical thinking. There's also issues with ethics, authorship, bias, misuse, cheating, environmental considerations. The list goes on and on. I think we're going to have solutions to many of those things. I'm very heartened by advances in neuromorphic computing and also new architectures that are radically driving down the cost in terms of energy and water usage for using LLMs, certainly for inference, but also for training. As many of you know, these tools are quickly evolving into platforms that make it easy to do computational thinking, just like we've done before with spreadsheets and search engines and databases and SQL and all this other good stuff. If you use the very latest versions of ChatGPT, you'll see that you've got a bunch of cool options to choose from. There's a whole bunch of different models, each of which has its own pros and cons. One of the things that's going to happen supposedly by this summer is we're going to get ChatGPT 5, which is going to merge all of these choices into a single unified magic interface. So they're going to have one prompt window, and then it will figure out the best way to solve the problem that you ask it. So I had some other fun. I decided I would take the data I got earlier and I would overlay it. So here's the computer science trends over time. Here's the data science trends over time. And I think it's kind of interesting to see it's growing faster. And that leads to some very interesting questions. How do we think about using these tools? So I firmly believe that the future in our fields, computer science, data science, and beyond, will belong to people who know how to ask the right questions and then know how to make sense of the output. So when I gave a talk recently at the Sunken Gardens for the class of 1975 Old Guard induction luncheon, one of the questions that I wanted to address was, what is William & Mary education? Why does it still matter? Well, it still matters because it's not how you ask the questions to the LLMs that are important. It's what you do with the output and the questions you ask of the output. And that's what requires ethical reasoning, critical thinking, systems thinking, integrative skills, and so on. Those are precisely the things that we've always been good at. And it's even more important today to have those skills because it's so easy to get into this trap where you let the AI do the thinking for you. Here's a great thing. I'm sure some of you have probably done this. Dan has probably done this because he has little kids. You use generative AI to say, generate an app, a mobile app, a website, whatever, that'll keep my kids entertained because we're going to go on a trip. And in very short order, it'll figure out how to do that. It'll ask you some questions and boom, you've got your website, you've got your mobile app. All you had to do was think it and it just comes into fruition. So I think that's pretty darn cool. What can we be doing to prepare our students and more importantly, ourselves for this brave new world of AI? We don't have to throw the whole curricula out the window, but we should start asking ourselves, how can we embrace natural language programming for certain assignments or certain portions of assignments? Allowing people to cross the bridge from traditional programming to natural language programming. I would say 90% of the computational thinking, probably more like 100% of the computational thinking I do these days, because I have very little time to program the way I love to program in Java or C++, is done in exactly this way. I'm using natural language to get the results I want. It's very important that we teach our students how to use this emerging generation of AI-augmented tools. When I went to school here, again, we learned Pascal on a prime computer. They'd make us draw out our programs as a flow chart before we wrote any code. It was dreadful. By the way, I had wonderful teachers in computer science at William & Mary. If that's what we were still doing in our computer science or data science program, we would have 0 majors. People would be like, why are you teaching me this crap? This makes no sense. It's so old school. We need to get to the point where we're teaching our students how to use the latest tools. Now, these are mostly coding tools, and not everything in data science is about coding. But people should be using Windsurf or pick your favorite thing and getting very facile with it. Why does that matter? Because when you hit the workforce as a student, you're not going to be able to differentiate yourself in terms of your depth of domain knowledge. People have many more years of experience than you. If you're lucky, you'll be able to do it because you have newer understanding of how to use tools. That could be your differentiator. If we let people out there who are still doing the write code in the third generation language and debug it manually approach, they're going to have a really hard time differentiating themselves in the market. Some other things we can do: encourage students across schools and across majors in our own school to use these AI tools to think algorithmically. This is a little thing we've put together. Higher education institutions in the state of Virginia and beyond. Historically, people thought of us as being arts and humanities and social science. And we've always had this relatively good, relatively small student-faculty ratio. For years, that's pretty much all people thought of William & Mary as being, even though we've had physics for hundreds of years, we've had PhD programs in physics for 60 years, computer science, PhD programs and programs for 40-some years, and so on. With the new school of CDSP, plus the focus that the business school is doing on AI, we are going to develop a reputation for doing great stuff in STEM and technology. So that's good, we have more balance, but there are other places in Virginia that do that well too, like UVA. So what is it that differentiates us from them? Well, it's really this piece here, this last piece of the Venn diagram, where because of our good faculty-student ratio, we can give people real-world challenges with high faculty-student engagement. And I think that's the sweet spot. So we have to figure out ways to enable and facilitate that. What are we doing about this, you might ask? Well, people here are working on coming up with a BA in digital reasoning. And the idea here is to make it possible to have a secondary double major with people who would major in economics or sociology or psychology or kinesiology or whatever. I think that's going to be wildly popular, and we'll talk about why in a second when I show you some statistics. The other thing that we're working on, and I think we're very close to being able to do this, hopefully, knock on wood, by the fall, if the stars and the planets align, is have some kind of artificial intelligence specialization, which is conjoining of computer science and data science. And we've got some really cool ideas of how to make this work. I think this will be really, really popular. And what we'll do it in a way where to get this specialization, you have to double major in data science and computer science. And I think that will be really, really popular. Another issue is to think about how to institute this holistically or individually within our curricula. In a programming class like CS 141 or 242 or whatnot, we could start doing coding with tools like Windsurf. So you combine prompting and regular coding. More holistically, we should be thinking about how we take many different courses throughout our curricula, including things like the software engineering courses, and rethink the whole way that the software development lifecycle, the system development lifecycle is going to be radically different very soon. And we can also look at this in a bigger picture way. And I'm actually working with some of my colleagues at the Software Engineering Institute on those kinds of bigger picture items. We need to prepare for the future where programmers are vastly outnumbered by computational thinkers. And this is why it matters for us. These are some statistics I got. Dane Pascal, who's the chief data officer at the moment, he sent me a spreadsheet with a list of all the majors and minors at William & Mary for 2025. I threw that into ChatGPT and said, please come up with a visualization of the top 15 departments sorted from most popular majors, from highest to the 15th. You can see here, computer science is currently 5th, data science is something like 13th or so. If you think about computer science and data science together, which is what we'll be doing with this AI specialization, we're number 1. We've got the most interest. The next thing that's interesting, this is the minors. First of all, CS isn't even on this list, and that's by design, but data science is way ahead of everybody else, like 2 to 1 over the next most popular minor, which is psychology. My hypothesis, hopefully be proved out through evidence in the not too distant future, is once we have this BA in data reasoning or whatever we call it, those numbers will probably drop, but a lot more people will be taking that double major. And that would be super, super exciting. The last thing to just point out about this, right now when people hear the word prompt engineering, they largely think parlor tricks to get the LLM to do my bidding. But it's really a lot more than that. And it's going to be thinking about using prompting throughout the life cycle. Just like software engineering is not the same thing as programming or software development. Prompt engineering is not just about prompting. It's really about thinking of how we're going to do quality assurance, testing, maintenance, configuration management, all the things that go into the life cycle of building large systems. Why is that important? Because if we can't figure that out, we'll only ever be able to do prompting in the small. We won't be able to do prompting in the large. People who only know how to do prompting in the small and then they try to use it for bigger systems will quickly run into mountains of technical debt where they will create a lot of junk and it'll collapse under its own weight once you have any kind of turnover or requirements change and so on. There's a whole discipline that's only beginning to be thought through about how to do prompt engineering in the large. And the last thing I'm going to leave you with here for something completely different, anybody here who remembers Monty Python, is this from Virginia Commonwealth University, this link down below. They have come out with an 18 credit hour AI minor in humanities and sciences. And if you look at these courses, it's absolutely fascinating. We've got anthropology, we've got English, we've got history, we've got math, we've got philosophy, we've got physics, we've got stats, and so on, and political science. And every one of these courses is being rethought to have some relationship to AI. That is transformational. So why does this matter? Because people are very quickly starting to ask themselves those hard questions, like the millennials and Gen Z people, like, why am I bothering to go to college? It doesn't pay off for anything. And if we're not careful, other places are going to grab onto that. And they're not going to grab onto it just in the CDSP type thing, the STEM place. They're going to be grabbing onto that in all these other fields. And a lot of those fields are the ones that people have traditionally come to William & Mary for. And if all of a sudden you can't get that kind of an education at William & Mary, but you can go to VCU and get that education, people are going to start asking themselves really hard questions about why they're going to where they're going and what's the payoff. That's why I'm so excited about the BA in digital whatever, because I think that will allow us, with people from arts and sciences, to start getting into this game fast. And the rest of arts and sciences can evolve at whatever rate they choose, but I think if we work together, we can get awareness raised very quickly. And the last thing I'll leave you with here, King Canute was a king, and he wanted to show his sycophantic advisors the limits of kingly power. So he went to the seashore and he said, "I command the waves to stop." And of course, the waves didn't pay any attention to him whatsoever because he had no control over them. And they continued to wash onto the beach. So anyway, that's what I wanted to talk about today. Hopefully that's entertained you and maybe enraged you.